see if you had a lens the size of a galaxy.
Looking back more than 13 billion years, light travels at 186,000 miles per second.
The James Webb Space Telescope has made a shocking discovery that's puzzling scientists. It discovered a structure that shouldn't even exist going by what we knew about the formation of galaxies over billions of years. This unexpected structure has shaken up the scientific community, going against established laws of science. Imagine finding something completely out of place in your room when you're sure it shouldn't be there at all. That's kind of what's happening here. But how could such an alien structure appear out of nowhere? And what cosmic forces could have conspired to birth this alien structure that shouldn't even have a place in the cosmos? Come along as we explore how the James Webb Space Telescope discovered a structure that shouldn't exist. JWST's cosmic dust penetration. Cosmology, the exploration of the universe's vastness and evolution on its massive scales, is a field that continues to grow and thrive. As our technology improves, we explore deeper into space, finding amazing things. Leading this exploration is the James Webb Space Telescope, an advanced telescope named after astronomer James E. Webb. It's the biggest and most powerful telescope ever made, and it recently found something unexpected in space that doesn't fit what we thought we knew about how galaxies form over billions of years. We'll learn more about this as our exploration continues. You see, the main mirror of the telescope is huge, 6.5 meters across, made up of 18 pieces that unfold like a fancy origami flower. This vast mirror and its advanced infrared sensors empower the JWST to peer back in time, capturing light from the universe's dawn, only 250 million years after the Big Bang. The core mission of the James Webb Space Telescope transcends mere observation. It aspires to revolutionize our comprehension of the cosmos. By looking far into space, it aims to solve mysteries about how the universe began. It wants to show us how stars and galaxies formed, understand how space structures changed over time, and maybe even find planets where life could exist. One of the telescope's big features is its ability to see infrared light from faraway things in space. This helps it see through dusty areas that block regular light, letting us see parts of space we've never seen before. Finding new galaxies is important because each one teaches us something new about how the universe works. By studying these far-off galaxies, scientists learn about lots of important space stuff. They figure out how stars and planets are born, understand more about mysterious things like dark matter and dark energy, and get a better picture of how everything in space fits together. And now here comes the most interesting aspect: JWST's icy gaze at galaxies from the early universe. The James Webb Space Telescope achieved groundbreaking discoveries in July 2022 by capturing images of galaxies merely 620 million years after the Big Bang. These galaxies are the farthest observed to date, significantly advancing our comprehension of the early universe. They unveil the emergence of the first galaxies from an ancient chaos. What distinguishes this telescope is its extraordinary size and capabilities. It stands as the largest and most potent space telescope ever constructed, specifically engineered to detect infrared light. Its primary mirror, at 6.5 meters in diameter, surpasses the Hubble Space Telescope's mirror by threefold, enabling the JWST to gather 4 times more light and peer into fainter, more distant celestial objects. Moreover, the JWST operates at an exceptionally low temperature compared to the Hubble, which significantly enhances the sensitivity of its infrared detectors. While the Hubble functions at about -123 degrees Celsius, the JWST operates at a chilling -218 degrees Celsius. Equipped with 4 scientific instruments, the JWST focuses on different aspects of celestial exploration. The near-infrared camera captures images within the near-infrared spectrum, akin to visible light, and is utilized to scrutinize a diverse array of cosmic entities, such as stars, planets, galaxies, and nebulae. The near-infrared spectrometer studies the spectra of objects in the near-infrared spectrum, aiding astronomers in analyzing their chemical composition and observing their movements. The mid-infrared instrument takes images within the mid-infrared spectrum, considerably distant from visible light. Its primary function is to study specific entities, such as dust clouds and nascent stars. The fine guidance sensor, near-infrared imager, and slitless spectrograph operate in tandem. The fine guidance sensor ensures accurate pointing of the telescope, while the slitless spectrograph captures images and spectra of objects within the near-infrared spectrum. Unlike the Hubble, which detects visible light, the JWST explores the infrared spectrum, allowing it to examine a different facet of electromagnetic waves. In its mission to scrutinize the origin, nature, and formation of galaxies while searching for exoplanets, the JWST recently discovered 6 new galaxies. These galaxies, appearing as minute reddish dots due to their immense distance, provide amazing glimpses into the early days of our universe. However, these new revelations challenge existing theories about the appearance and evolution of the early universe, conflicting with earlier observations made by the Hubble Space Telescope. Now, let's seek the input of experts regarding this issue. Red stars and massive galaxies rewriting history. According to Joel Leja, an assistant professor of astronomy and astrophysics at Penn State and one of the study's authors, there were specific expectations about the types of galaxies present in the early universe. Typically, these galaxies are young and small and appear as small blue baby galaxies. Previous studies using instruments like the Hubble telescope have identified such early galaxies as recently formed, evolving structures that emerge from the cosmic soup, developing their stars and structures. Ordinarily, young stars shine bright blue, gradually adopting a redder glow as they consume their fuel and cool down. However, the surprise arose when the Webb telescope, designed to spot ancient galaxies, revealed old red stars, which was unexpected. Moreover, discovering galaxies 50 times more massive than previously estimated was equally astonishing. Some of these newfound galaxy candidates were as massive as our Milky Way, when the universe was only 3% of its current age, leading to significant astonishment among scientists. Leja emphasizes the need for caution before redefining cosmological theories. Before astronomers can rewrite these theories to explain the rapid formation of these galaxies post the Big Bang, they need to ensure that these peculiar red dots they're observing are indeed galaxies and not something else. Exploring alternative explanations, such as stars emitting light differently due to the lack of heavy elements, or revisiting our understanding of how stars form, could provide exciting insights. These possibilities could revolutionize our comprehension of early star formation, but in a significantly different way. He underscores the importance of using spectra to precisely determine the distances to these objects, establishing a correlation between distance and object identity. This approach helps verify if their hypotheses about these distant objects are accurate. The rapid challenge scientists face in rethinking their theories about the early universe, merely 6 months after the Webb team's initial observations, is extraordinary and somewhat unimaginable. While the observed objects seem to resemble galaxies, there's a chance that some of them might be supermassive black holes, adding a layer of uncertainty to these discoveries. The most fascinating cosmic entities are black holes, regions where an immense amount of matter is squeezed into a space millions of times more massive than the Sun. Here, gravity is incredibly strong, preventing even light from escaping. The discovery of potential black holes among the 6 cosmic findings reflects a significant change. Regardless of the specific identities of these objects, the total mass discovered challenges existing scientific beliefs. It suggests that the total mass of stars during this early cosmic period could be up to 100 times greater than what scientists previously estimated. These discoveries, informally termed universe breakers by the study, defy what many astronomers considered settled science. Joel Leja, reflecting on these findings, highlighted that exploring these objects in the early universe for the first time has surprised them immensely. These cosmic revelations create profound challenges for science, calling into question the established understanding of early galaxy formation. Unraveling the Webb telescope's 6 universe breakers. Now, delving into the specifics of these unearthed celestial bodies found within the expansive cosmos field, a region teeming with galaxies. Each of these 6 galaxies holds its wonder and mystery. The first, GNZ11, stands as the most distant galaxy observed to date. Despite its early formation, it surprisingly possesses a mass 89 times greater than our Milky Way, challenging our understanding of galaxy formation. The second, GZ10, situated about 133 billion light-years away, exhibits an extraordinary brightness, surpassing astronomical predictions by nearly 100 times. This revelation hints at potential accelerated star formation processes in the early universe. The third, GNZ9, showcases abundant heavy elements essential for life, suggesting that early star formation and supernovae events were already underway, crucial for the emergence of life. The fourth, GNZ8, challenges existing models of galaxy formation with its structured disk, suggesting that disk formation might have occurred earlier than previously thought, potentially reshaping our understanding of galaxy evolution. The fifth, GNZ7, rich in dust crucial for planetary formation, hints at the early beginnings of planetary systems in the universe. The sixth and final one, GNZ6, stands out due to its surprising redshift, suggesting intriguing possibilities about the large-scale structure of the cosmos. The discovery of these 6 galaxies, made possible by the James Webb Space Telescope's incredible capabilities, represents a monumental leap in our comprehension of the early universe. By scrutinizing these distant galaxies, astronomers aim to unravel the secrets of star and galaxy formation, cosmic evolution, and the potential existence of habitable exoplanets. These discoveries challenge established theories, pushing us to rethink and deepen our understanding of the cosmos and its origins. The new findings suggest some really important things about how galaxies formed in the early universe. First off, these discoveries challenge what we thought we knew about when galaxies started forming after the Big Bang. The James Webb Space Telescope found galaxies that existed just 300 million years after the Big Bang, which is earlier than we believed before. This shakes up the idea that galaxies began forming around 500 million years after the Big Bang. Another big deal is that the discovery of some massive galaxies, like GNZ11, hints that stars might have formed way quicker than we thought in the early universe. These big galaxies popped up within a few hundred million years after the Big Bang, suggesting that making stars happened way faster back then than we realized. Also, seeing galaxies with weird-shaped disks, like GNZ8, challenges our ideas about how galaxies formed. These disks usually come from gravity in galaxies, but the early universe was too chaotic for these disks to form. So the fact that GNZ8 exists makes us think these disks might have appeared earlier than we thought, which could change how we understand how galaxies evolved. Finding heavy elements, like GNZ9, in galaxies tells us that explosions from massive stars, called supernovas, made these elements happen earlier than we thought. This could mean that the universe's chemical changes happened faster than we realized, which might affect how planets formed and the chance of life appearing early on. Lastly, these discoveries are making us rethink our models of how the universe works. We've got to update our ideas to include galaxies forming earlier, stars being made quicker, and heavy elements appearing sooner in the universe. It's challenging what we thought we knew and giving us a deeper, more complete picture of the universe. But it doesn't end here. discoveries and paradigm shifts ahead. As newer and more advanced telescopes join space exploration efforts, we anticipate even more groundbreaking discoveries that will shape our understanding of the cosmos. The recent findings about galaxies hold significant importance for future space missions and studies of the universe. These discoveries have opened up new paths for research and highlighted the necessity for more powerful telescopes to explore deeper into space. The discovery of galaxies in the early universe offers a special chance to explore how galaxies formed and changed over time. By studying these distant galaxies, scientists can learn about how the universe began, the processes behind the first galaxy's formation, and how these galaxies evolved over billions of years. The James Webb Space Telescope has been crucial in these discoveries, and upcoming space missions will build on its success. For instance, the Vera C. Rubin Observatory, starting in 2024, will survey the sky extensively, enabling astronomers to detect and study a large number of galaxies, including those recently found. The discovery of galaxies with lots of stars and specific shapes suggests that dark matter might have a more complex role in how galaxies form. Also, finding galaxies in areas where expansion happens a bit slower might offer new insights into dark energy. Future missions like the Euclid Space Telescope and the Large Synoptic Survey Telescope will delve deeper into dark matter and dark energy, refining our understanding of these mysterious elements of the universe. These missions will measure how galaxies are spread out and how the universe expands, helping us understand these cosmic components better. Moreover, discovering dust in galaxies like GNZ7 suggests that planetary systems might have started forming early on in the universe. This raises the possibility of habitable planets existing in these far-off galaxies. These discoveries of early galaxies show how different aspects of cosmology are interconnected. Studying how galaxies form and change gives us insights into dark matter and dark energy, the universe's chemical changes, and the chance of life beyond Earth. This calls for future cosmological studies to bring together these different areas to create a complete understanding of the universe from its start to the present. This will require collaboration among astronomers, physicists, and other scientists, leading to a richer understanding of the grandeur and complexity of the cosmos. With these discoveries, and many more expected in the future, scientists and astronomers might need to rethink our established ideas and theories about the universe. It's an exciting time of re-exploration and reconsideration of our understanding of the cosmos. Which of JWST's groundbreaking discoveries intrigues you the most? Let us know in the comments.